Okay, so in this question, we will assess application of real gas equation of state. The question is 100 kilogram of butane is kept at pressure of 50 bar and the temperature of 40 degrees Celsius. So in this case, we need to calculate parameters A and B for the van der Waals equation of state and calculate the volume. In fact, it should be specific volume occupied by butane at the given conditions using the van der Waals equation of state. So this is the question. So let's write van der Waals equation first, which is pressure is equal to R universal gas constant, temperature over specific volume minus B, which is a coefficient, minus A, which is another coefficient, over specific volume square. So A and B are coefficients, if you can see this. So A is you see this, A is coefficient which represents attractive forces between the molecules, and B is volume occupied by the molecules of the gas, because in ideal gas we assume A and B doesn't exist and they are equal to 0. That's why we get PV is equal to nRT. But in real situation, these are not 0 and these are considered in real gas equations because they are not assumptions anymore in real gas. So A is representing attractive forces between molecules and B is volume occupied by the molecules of the gas. So they have different formulas for that. So A is equal to 27 over 64 universal gas constant, critical temperature square, and PC, which is critical pressure. And after that we have B, which is R universal gas constant, critical temperature over 8, PC, which is critical pressure. So basically this is different formulas. These are different formulas. We have butane given in our question. For butane, data is given. For butane, critical temperature is 425.2 Kelvin. Critical pressure is 37.9 bar, and universal gas constant value is 0.0831 bar liter over mole Kelvin. So these are the data or information which is given for butane. Now simply first question is we need to calculate parameters A and B. So let's calculate A, which is given in the formula. So let's put the values. Everything is given. So A is equal to 27 over 64. R is 31 bar liter over mole Kelvin multiplied by a critical temperature which is 425.2 Kelvin, and this is whole thing is square, over critical pressure which is 37.9 bar. So these are the information which is given. So we can cancel few units, like Kelvin is cancelled with Kelvin, and as a result we will get A is equal to, if we multiply this information, and we will get 14 as a numeric number, units bar square liter square over mole square and bar. So one more bar is cancelled with one bar, so as a result we will get A value is equal to 14 liter square bar over mole square, right? So this is a value of A, right? Now the same approach we can apply for calculating B, which is B is equal to RTC over 8PC. So again, R is 0.831 bar liter over mole Kelvin multiplied by critical temperature is 425.2 Kelvin over 8. PC is 37.9 bar. So in this case you can see Kelvin is cancelled with Kelvin, bar is cancelled with bar. So we will get liter over mole. So the B value which we will get as a result, you can multiply this. B value would be around 0.12 liter over mole. So this is B value, so that means A and B both are done. A and B, like part A is done. Now part B is calculate the volume occupied by butane at the given condition using van der Waals equation of state. For that we can use this equation which we have written already. So everything is given to us. Now I'm putting the values in that equation, which is pressure is given, which is 50 bar. So I'm writing this. So 50 bar is equal to universal gas constant, which is 0.0831 bar liter over mole Kelvin multiplied by temperature is 40 degrees Celsius, and we need to convert this into Kelvin. So temperature is 40 degrees Celsius, which is equal to, which is plus 273. So temperature becomes, let me double check, I think it's 313 if I'm not wrong, right? Basically, I'm just checking that. 40 plus 273, yes, 313 Kelvin. 13 Kelvin. So we can write this T as 313 Kelvin. Specific molar volume needs to be calculated. Minus B is calculated, which is 0.12 liter over mole, and then minus A is calculated, which is 14 liter square bar over mole square over specific volume square. So you can see this in this equation. We have got all the information except specific molar volume, which is small v, right? So if we will solve this equation, you can check using your calculator. So specific volume should be close to 0.64 liter per mole. So you might have different answer, but that's what I checked, I think. So this is a specific molar volume value after solving this equation, and this is really the application of van der Waals equation. And you have observed that how we can calculate different parameters of van der Waals equation like A and B, and also how we can use van der Waals equation to calculate specific volume in this case. I hope like this question is clear to you guys.